So I want to quickly sort of sketch what those vector fields look like. So notice that these guys are pointing in, and they sort of curve towards the axes. We're looking at that one from below.
Why is that one?
Oh no! Oh my gosh!
You gotta write the first time.
Oh, I had it right the first time?
Yes.
Oh no! Yeah. Okay. Yes, it was right. Oh gosh. Okay. Yes. No, those are pointed out. Okay, and then this one, everything is pointed inwards. Okay, so I want to point out a couple of sort of special features of these graphs. So here we're at a minimum point, right? The origin is a minimum of this function, and all the vectors are pointed away from our minimum. Okay? Here we're a maximum, and everything's pointed towards that maximal point, right? This will have a maximum at the origin. Okay? These two are what are called stable critical points. Okay? This is a critical point that once you get to it, you're kind of stuck there. And anything nearby would wind up having the same behavior. Same thing here. Everything nearby the critical point would have the same behavior. This, however, is a very interesting critical point. In some directions, we are a min, and in other directions, we're a max. Right? If you travel this way, you're increasing upwards. If you travel this way, you're decreasing. Okay, so here these are sort of stable points, and this guy's unstable. Good, so I'll write down our gradients. And this issue of stability, we can detect it by looking at our Hessian matrix. Okay, so to take our Hessian, we take the derivatives of our partials. So one thing that we can notice, and if you're in 223, you might notice this faster than someone who isn't, is that for the stable critical points, we've got a particular determinant. Here are determinants 4, -4, 4. Okay, for the stable critical points, we have positive determinant. This guy's positive, this guy's positive. For the unstable points, we do not have positive determinant.
Professor,
Yeah.
just out of curiosity, what would be if determinant is 0?
Right, if its determinant is 0, then you're sort of in some kind of a special case, and you need to do some more work. We'll talk about that. We'll do that work after the break. So here we've got a min. Here we've got a max. Right, and here we've got something that's neither a min nor a max. A point like that is called a saddle. And if we look at our graph, we can see that the origin is not a min nor a max. We go this way, we get smaller. We go this way, we get bigger. This is sort of unstable somehow. Okay, so we'll come in after the break and talk about what these three things mean and what the sort of second derivative test is for them. But let's pick that up at 210.
So stable is like we're not operating in the same direction.